Hello students, welcome back. So in the next section, we'll be looking at the volume and the total surface area of a sphere, right? So over here, there's an interesting story about how this Greek mathematician, right, Archimedes, he actually figured out a way to actually measure the volume of the sphere or any shape, any irregular shape for that matter, right? So I'll leave it to you to read it on its own. If not, just do a quick search online. There are many very good storytellers who share this story. You don't need me to tell you this story, but it's quite a fun story, so you can read it. But let's go down to the real business here, right? So what we want to figure out over here is this, right? So if you look at some of the experiment you can find online that some other people may have actually shared, is that the volume of water displaced when we put in a sphere into a cylinder with the same circular base, right? You will find that the amount of water that's displaced is 2/3. So what this means is that the volume of the sphere is actually, let me change the color of my pen, is actually 2/3 the volume of the cylinder, right? So that means it's 2/3 base area times height, and for cylinder the base area is pi r square. The height in this case we want it 2r because we are using a cylinder that has the same height as the sphere, right? So it's 2 times the radius, so that's the diameter. Okay, so 2/3, and when we simplify them together, we will get 4/3 times pi r cubed, right? So the volume, let me write it clearer here, is 4/3 pi r cubed. This is the volume of a sphere, okay? There are also mathematical proof for it, but it's beyond your curriculum and your syllabus for now. It's something for your future, right? So there is also another technique that Archimedes used to actually calculate the total surface area. Again, I leave it to you to read it because it's all right there in your handout, okay? But just to quickly get to the main point, right? The total surface area is 4 pi r square. I can share this story with you, of course, but maybe in person, right? So for this video, let's keep it to the main points, right? So total surface area is 4 pi r square. The volume is 4/3 pi r cubed. Good to remember them. So with this, we can actually answer some of the practice questions. So here we have a first example. We have a lead ball, a ball bearing, right? A small little sphere. It has a diameter of 0.4 centimeter and the mass of 5,000 of this, right? Is what you are supposed to find. Okay. But we are told that 1 cubic centimeter of this lead, right, is actually 11.3 gram. So sure. So let's work out the total volume first, right? So from the total volume we can actually multiply by 11.3 to get the mass. So how do we do it? Volume of ball bearings, right? Of ball bearings equals, right? So 4/3 pi, the r, again, take note, right? Sometimes the question gives us the diameter. You need to be aware of this and realize that the radius is half of that. So it's 0.2 to the power 3. And there are 5,000 of these balls, of these lead balls, right? So you work this one out, it'll be 167.5516, etc. Okay, yeah, there we go. Okay, so we have the volume. So to find the mass, therefore, the mass is equals to 167.5516 multiplied by 11.3 gram, which will end up as 1890 gram, corrected to 3 significant figures. There we go. Okay, right, another example. This time around we have a solid hemisphere. Hemisphere is half of the sphere, right? It's a curved surface area of 175. Find the radius. So we know that the surface area of a sphere is 4 pi r square. And since this is a hemisphere, I'm going to take half of it, and half of it is 175. Okay, so from here we can work it out. Pi r square is 175/2. Let me scroll up a little more space, right? So r square is equals to 175/2 pi. R is square root Well, we just need the positive value, right? Because r represent the length, so we do not need the negative value of r, because we don't get negative length. It doesn't make sense, right? So you work this one out. This will be equals to 5.28 centimeter. Again, this is corrected to 3 significant figures. Okay, right? So with this, in the last section, in the next video, in the last section, we will just be looking at composite solids, and that will actually round up what we need to know about mensuration for now. Right? Have a nice day.